अद्य अन्तिमसत्रम् इति वयं वक्तुं शक्नुमः, परन्तु कार्यशालायाः अन्तिमं नास्ति, अद्य अन्तिममस्ति। तर्हि अन्तिमपर्याये चतुर्थसत्रे वयं स्मः। अधुना वयं पुनः एकवारं सर्वेषाम् अध्यापकानाम् एवं छात्राणां च स्वागतं करोमि। अस्मिन् सत्रे पुनः अस्माकं विशेषरूपेण विषयविशेषज्ञ महोदया प्रोफेसर् एन् कलया ऋषि महोदय अस्माकं बोधयन्ति स्टाटिस्टिक् विषये। पुनः वयं अबोधनं कुर्मः। महोदय विस्तृतरूपेण पुनः पाठयन्ति इति महोदयानाम् अनुरोधे भवत्याः प्रस्तुतिं प्रकटयन्तु इति सम्प्राप्ते।
When you look at the statistics, you can look at the 2 points. One is inferential statistics, another one is descriptive statistics. There are yet another classification, parametric test and non-parametric test to test the hypothesis. So now we are getting into inferential statistics. Inferential statistics, the name was given like that. The inference statistics is studies which helps us to draw inferences. Descriptive statistics tells us only to describe the information. For example, mean, median, mode. You can only describe. The mean is 45. The mean is 72 We cannot draw much more inference out of it. Whenever you do a t-test, ANOVA, chi-square test, z-test, where you can draw inference, you can get a meaning out of it. You can have better understanding about the data. So statistics used for such purposes are known as inferential statistics. So in inferential statistics, whenever you want to test the hypothesis, you will use either parametric or non-parametric test. If you want to apply parametric test, certain conditions need to be followed, need to be adhered to. If you don't know anything about the distribution, then conveniently we can go for non-parametric test. If these conditions are not satisfied to apply parametric test, we can switch over to non-parametric test. Okay. So next slide. Difference between parametric and non-parametric. This we'll skip. I will discuss in next class. This is what I get. Goal of inference statistics to make generalizations about the population. So I draw a statistics. I do certain values. I am getting a value from this. We are going to generalize to the population. Inference statistics helps us to relate this result with the population. That's what inference we are trying to make out. All your PhD researchers can be considered as we try to generalize this to the general population. So they are applying inferential statistics. Inferential findings help us to generalize, to extend the result to general population. Okay? Yes. Inferential statistics, the statistics is taken from the sample data and this is drawn, extended to the whole population also. That's why from the statistic we can go to parameter. I told you earlier, remember? From the sample data, sample information, I can go to the, you can draw conclusions for the general public, general population. Okay, next slide. Next one. This I given the difference statistics, difference between inferential and descriptive. Inferential used to draw the conclusion about population by using analytical tools on the sample data. You apply the tools, you apply the statistical tools on the data and draw conclusions and extend to the general overall population. Whereas descriptive statistics are used to quantify the characteristics of it. This is the mean. This is the research aptitude of this group appearing for the workshop. This is only descriptive statistics. The average research aptitude of the participants of this workshop only tell you what is the aptitude. We cannot draw anything beyond that. Whether female and male participants differ in their research aptitude. That is inferential statistics. Do you get the point? There are set of female participants, set of male participants. Do they differ in their research aptitude after attending the workshop? Or attitude of the participants after attending this workshop? Does it vary? Suppose they are given one tool before this workshop. They are given the same tool posters after the workshop. Do you get the point? Is the research attitude vary between before and after the research workshop? there you will use inferential statistics. You get my point? You can draw the inference out of it. Yes. Now hypothesis testing and regression analysis are analytical tools generally use inferential. Hypothesis testing involves everything. T-test, F-test, chi-square test, all these things comes under hypothesis testing. Even regression analysis and all comes under inferential. Whereas measures of central tendency, measures of dispersion, mean, median, mode, range, standard deviation, quantitative average deviation, they are only describes. You cannot draw any meaning out of it. You cannot generalize those, from this you cannot generalize to the general population. Okay, that's the system. It is used to make inference about unknown population. I know the statistic from this unknown population and drawing inferences. Whereas it only talks about the existing population. The sample from which I am getting only I can talk about the sample. I cannot generalize to the whole set of students doing Sanskrit throughout the India. No. Only for this population sample I can talk about. Next is measures of inference statistics are t-test, z-test, linear regression, and so on. Whereas dispersion are, as I told earlier, mean, median, mode, range, standard deviation, quantitative deviation, and so on. Okay, next slide. Now we are getting to the big topic, ANOVA, analysis of variance. What is this analysis of variance? Suppose there are two groups you are comparing, who is performing better. Okay, there are 5 groups. How can I compare? When there are only 2 groups, you are able to compare easily using which test? What is the statistical analysis used to test whether 2 groups differ or not? T-test. Very good. T-test used to test whether 2 groups differ or not. There are 5 groups. They say for mathematics major, physics major, chemistry major, okay, Sanskrit major, and sociology major. There are 5 groups. Who has got higher research aptitude? How to compare? There are 5 groups are there. You get my point? We want to find who is higher, who is lower, who is moderate, and so on. What to do? How many t-tests to do? At a time we can only compare 2 groups at a time. Okay. 1, 2, 3, 4. 4 t-tests. Okay. Then 5, 6, 7 t-tests. 8, 9 t-tests. 10. So you have to do 10 t-tests. Do you get my point? To compare 5 groups, we need to do 10 t-tests. It's a very laborious process. Is it not? Computing 10 t's. Instead, you can do ANOVA. You can do analysis of variance. If that value is significant, you are going to do big calculation, you are going to arrive at one value. That value is known as F. ANOVA is also known as F-test because it was propounded or invented by Fisher. So following his name, ANOVA is also known as F-test. Analysis of variance, short form is ANOVA. It is also known as F-test. So instead of doing 10 T's, you will do 1 F. Calculate the F. If that F value is significant, when will you say the value is significant? When the obtained value is greater than the table value. When you say the value is significant? When the value that you are arriving at by doing the calculation, you are going to arrive at one value. When the obtained value is greater than the table value, you say it is significant. When the F value is significant, you go further, do this post-hoc test. We say that as post-hoc analysis. There are Duncan post-hoc, Sheffy, Turkey, number of post-hoc tests are available. Okay, that's why you got DMRT, Duncan multiple range test. In one topic you are given DMRT. Okay, so when F is significant, you do post-hoc test to see which means differ. Which parts of T is different. There are so many 10 pairs now. All the 10 pairs need not be different. Need not be significant. There are 10 T's. All the 10 T's need not be significant. Either 4 T's can be significant or 6 T's can be significant. Rest of the 4 will be not significant. To see which are the pairs differing. So you go for T after ANOVA. Suppose while doing ANOVA itself, your F value is not significant. That is, the obtained F value is less than the table value. What will you do? When the obtained F value is less than the table value, you accept the null hypothesis and say no difference. We'll stop there. No need to do all the 10 please. This is the purpose of ANOVA. Understood? When more than 2 groups are there, only when 2 groups are there, you go for T. When more than 2 groups are there, you will do ANOVA and see whether the ANOVA value is significant or not. If the ANOVA obtained value is greater than the T value, greater than the table value of F, you will reject the null hypothesis and say that the groups are differing. F value is significant, so the groups are differing. Now my question is, which are the groups differing? Because there are 10 combinations here. When I take 5 groups, there are 10 combinations. Okay, so which groups are differing? All the 10 need not be differing. In that 4 can be different, 6 can be different, only 2 can be different. That's how the 8 will be insignificant. To see which pairs differ, you go for post-hoc t-test. Do you get my point? So this is the purpose of such a sophisticated analysis. When you have more number of groups. Okay? So this is one. It provides overall test of, this is what I given. It provides overall test of significance among several means. Now 10 means are there. Okay, it gives overall significant or not. Suppose your F value is not significant, what will you do? All the 10 groups are not significant. We'll stop it. Do you get the point? They are all alike. More or less alike. They are not significantly differing. All the 10 groups are not significantly differing. They are more or less similar in the particular trait which you are measuring. This also allows us to test the interaction factors which is not possible with the test. T-test you can have only 2 groups. Suppose there are, this here only comes a 2-way ANOVA. 2-way is another big process. Suppose male, female, maybe male teachers, female teachers, and you have 3 methods of teaching. One is traditional method, chalk and talk method. Another one is multimedia method. Third, project method. So 3 methods are used in a research. Okay, one is traditional chalk and talk method. Another one is multimedia method, and third method is project method. Then there are 3 groups now. What analysis will do? ANOVA. Very good. So, but only one teacher was involved here. The same teacher is going to one class, teaching the traditional method. The same teacher goes to another class, teaches by multimedia method. The same teacher goes to third class, teaches by project method. You get my point? So, teacher is the same. Suppose you have 2 teachers. Teacher 1, teacher 2. Teacher 1 goes to 3 methods. Teacher 2 also adopts 3 other methods. Correct? Which teacher is better in which method? That is interaction. Third point. Okay, that is known as 2-way ANOVA. It is 3x2 factorial design. 3 methods involving 2 teachers. So those interaction may pay. One teacher may be very good at project, one teacher may be very good at multimedia, another teacher may be very good at traditional method. Who is doing better? As a result, which students are getting higher scores. That is only 2-way ANOVA. Understood? Yes. So ANOVA helps us to find out the interaction effect. When there are classification in both ends. Here also classification, here also classification. Teacher 1, teacher 2, here method 1, method 2, method 3. Understood? Yes. Next one. Again, the same conditions which you would apply for parametric test law, that should be satisfied also. You remember, condition to apply parametric test. What are the conditions? Normality, and the homogeneity of variance. Additive, this is extra point. Additive effect, basic model of order, a given observational score is a sum of certain components, each due to the effect of a particular identified source of variation. Here you get source of variation. Electronic typing, source of variation. The additive effect, there are main effect and also error component. There are main component as well as error. It's the additive of 2 factors. Okay? So when you come to problem, you will understand what I am trying to say. Third one, last is this also told you. You have to apply random sampling method. Only when data are collected, subjects are involved for research using random sampling method. Normality, parametric test can be applied. This is higher level, sophisticated parametric test. So this will also satisfy. All the conditions of parametric test should be satisfied for ANOVA also, because it is a sophisticated parametric test. Remember, I told that what are the conditions we applied for the parametric test? The same thing is applied except this one. This is additive effects which will always be there. I will come to that part when I do the problem. Okay, next one. Next slide.
Slide.
The formula for answer variance ANOVA coefficient. First, you have to find mean sum of squares between the groups divided by mean sum of squares, that is error component. MSS divided by MSE, MSB divided by MSE. Okay. Mean sum of squares due to treatment is, if it is going to be an experimental work, mean sum of squares due to treatment divided by mean sum of squares due to error. Degrees of freedom n minus 1. You know. Degrees of freedom for the groups, there are 3 groups, k groups, k minus 1. Degrees of freedom for the within the group, n minus 1 minus k minus 1. Because in ANOVA you will have total, you will have within, you will have between. Is it not? Total is n minus 1. Between is k minus 1. Within is n minus 1 minus k minus 1. That is n minus k. Okay, this is how you will find degrees of freedom for ANOVA. You will have 3 degrees of freedom. Which one? In the ANOVA you will have 3 additive factors. One is total sum of squares, between sum of squares, within sum of squares. For the total group, degrees of freedom is n minus 1. For within groups, there are 3 groups. Within groups, it is k minus 1. Number of groups is k. 3 groups is k minus 1. And between groups, total minus between equal to within. Always total minus between equal to within. So within groups, DF is n minus 1 minus k minus 1. Total minus between equal to within. Always in there. Okay? So now n is the total number of observations throughout all the k groups. I'll go to the problem, you will understand. Okay? Next slide.
Slide.
So I have given a problem.
Yes.
Steps involved in computation of F ratio. So 3 sets of scores given. Traditional method of teaching, multimedia method, and project method. Okay? These are the scores obtained by the students. Only one teacher now. The same teacher goes to all the 3 classes. He knows 3 different methods. So first, you add up all the scores. X1 sigma x1 equal to 60. Sigma x2 108. And just adding. That's all. Sigma x3 82. Here the sample says everywhere 7. It need not be equal. It can be different also. Not necessarily 7. One can be 7. One can be 8. One can be 9 also. No issues. But accordingly the value is going to change. Now total 7 plus 7 plus n 21. Clear? Now you find x1 bar, x2 bar, x3 bar. x1 mean, the mean of x1 is x1 bar. That is 60 by 7, so 8.57. Similarly, I am getting 3 means. Are these means different? Is it not? That is my question. Is it not? X1, x2. So now we have 3 combinations. X1 with x2, x1 with x3, x2 with x3. There are 3 combinations. Instead of doing 3 DCs, you will do 1 ANOVA. If that ANOVA values happen to be significant, I will go to this. If ANOVA value is not going to be significant, we will stop here. I will conclude all the 3 groups are not significantly differing. Got the point? Okay? Yes, next slide. Null hypothesis. How will you write? There is no significant difference in mean achievement scores of students who learned through traditional method, multimedia method, project method. Null hypothesis. No significant difference. That significant is very, very important. There is no significant difference between the mean scores of students who learn through multimedia method, project method, and traditional method. Okay? Yes, next slide. This is the formula. First step is correction term. First, you have to do the correction term. C. C equal to sigma x1 plus sigma x2 plus sigma x3 the whole square divided by n. We found sigma x1 on the first page. 60, 108 and 82. Add it, square it up, divided by total sources 21 items. 21 divided by 21. So I am getting C is 2976.2. Second is total, I showed you total sum of squares. You have to square every data in the problem. Okay? You go to the problem?
Yes.
Yes. You have to square everything. 6 squared plus 4 squared plus 14 squared plus 4 squared and so on. Add up everything square up to this. You get the point? For TSS, you have to square everything. 6 squared plus 4 squared plus 14 squared plus 4 squared plus 6 squared plus 1 squared 14 squared. Similarly, you have to add everything. So square of all the 21 items should be added. Minus C. You go to the third, next slide. So I am getting it as 6 squared plus 4 squared and so on. 10 squared minus C. When I add only 34.34 C, I am getting it here minus C. This is total sum of squares. Understood? This total sum of squares is the combination of between and within. That is why additivity of fx is there in the condition. The first condition, additivity of fx is there, no? I given the third condition to be satisfied as additivity of fx, normality, independence, remember? So the TSS is nothing but BSS and WSS total is only between sum of squares and within sum of squares, total is total sum of squares. So the sum of between sum of squares is individual total square. You go to the problem. Individual total is 60. 60 squared plus 110 squared plus 82 squared. Understood? TSS, we are squaring everything individually and adding. No, your total, the total you are squaring. There is always difference between 3 squared plus 2 squared. Otherwise, 3 plus 2 the whole square. This is not different. Definitely different. 3 squared plus 2 squared is 9 plus 4, 13. 3 plus 2 squared is 25. They are not the same. So T squared is, TSS is like this. PSS is like this. Understood?
Okay, madam. Our student wants to one ANOVA model. Is there any, for example, like this? How to testing the ANOVA? Is there any example, madam, like this? Sum. For example, F test is there, na? Whether the significant or not significant, how to prove it? Is there any model for it?
It goes further.
Yeah.
When you come to any country, you will
Our
understand.
students are eagerly waiting for that, but already theoretical portion is over. But how to do? It is our eagerly waiting.
Yes. I will come to it. After this, I will come to that. Okay? So, you go to the problem now. BSS is sigma x1 squared by n1, sigma x2 squared divided the corresponding n1 n2. So, you are getting this. Now, WSS, this minus this. Always within is total minus between is within. Understood? Either it's a degrees of freedom or sum of squares, everywhere total minus between is only within. So, WSS is TSS minus BSS. You are getting this much. Yes, next slide. So, this is now, you have to find the degrees of freedom. I told you for the total is total n minus 1 because 7 plus 7 plus 1, 21 minus 1. Now, between groups there are 3 groups. K minus 1, 3 minus 1, 2. Now, within is always total minus between is within. So, 20 minus 2 is 18. Understood? Now, this is how you put the table. This is how you put the table in the thesis. So, between groups, if it is going to be experimental work, it is variation due to treatment. Okay, survey test between groups. And then within groups it is variation due to error. To remove this only you are doing the statistics. Because we want to remove the error. After removing the error, is there any difference? That is the purpose of ANOVA. Even T is also the same. You are likely to commit lot of errors. As I told you earlier. Subject will correct there. Subject may ask his friend and put a tick. When you go and administer a tool, maybe in the back end of the session like this, if you are going to give a tool, at the close of the college, the boy will say, what am I going to put? I am going to put neutral everywhere and tick mark. Okay, you also put neutral. Otherwise the fellow will dictate. I will put one A, another one B, another one C. The next fellow also put like that. So these are errors committed by the students when you are giving the tools. So to remove all the errors and come to a conclusion, this error component, To remove the error component only you are doing ANOVA. Okay, yes.
Ma'am, can we level of significance 0.01 level?
Yeah.
What is the standard value of that F? This is the calculated value 5.0.
We have to refer to the table.
table, but they are saying that is the significant level, 0.01 level.
Level of significance.
Level of significant, but what is the level of significant in 0.0 level? F value. Do you know?
F value, it is there in the table. It is there in the table. You can go to the table also.
F table is different from T table.
Yeah. So here you want to look at for 2 degrees of freedom. F table you only look for 1 degrees of freedom.
Why? Because we are taking the 2 groups. That's why total number is 22 groups. N minus 1, N minus 2. That's total 20 minus 2. That is 80.
F table. Can you open F table?
Yes.
It is there.
And actually, to remove the human errors, you are doing
Scientifically you are trying to.
Before classes, Sir told that normal probability curve will become. Here, if you take the 5-point scale, the first scale and the last scale, in between what is there, that if we remove, the first and last will be significantly correct. Is it correct?
For which statistic?
Significantly correct. Okay, that's what you are asking. Please try to answer.
Yeah.
What do you want?
Actually, in a normal on a scale, 5-point scale.
So this is relevant. Anantaram the question.
Yes, yes. Okay.
Students are eagerly waiting how to check it.
Yes, yes.
Yes, please. F table question. F table.
See, in the previous one, what is K minus 1? 2. DF2.
DF2.
Another one is 18, is it?
Yes, 20 minus 2, that is 18.
18, yes. For 2, okay, 18. What is the value?
2.62.
Okay, this is F table. The standard F value. So your value
2.62. Calculated value?
is more. You go to the PPT.
2.62 is the table value. Calculated value?
18. 2.6. 5.06.
Okay.
Okay? So this is more. So it's significant not one.
Significant difference is
You
there.
go to the table. Go to the table. So here, this is
Double dip.
तदुपर क्लिक करो just please see it.
no, this is a spelling mistake. This is not one level. This is not one level table. Okay. There are one more table which gives both the values, not 5 and not 1. Not 1 will be given in the bold. Not 5 will be not bold.
Okay.
So always not 5 level is smaller. Not 1 level is bigger. If you look for not 5 level, it will not be 2.62. It will be something else. You get the point? It will be less than, definitely less than 2.62. 18. It is lesser only. Okay? It will be less. Since what is the PPT now? Let's go to the
Go,
PPT.
PPT.
Now the 5.06.
Calculated F
No,
value.
it is 3.55. Sorry, 3.55. Not 5 level is 3.55.
Table value.
Table value. Okay?
Okay.
Obtained value is more than the table value. So what you are going to do? Reject or accept?
Null hypothesis is rejected.
Null hypothesis rejected. Now I have to go for post hoc.
Post hoc. Okay. Yeah.
Do you follow? You have to go for post hoc. Then where you will come for 3 T's.
How to do post hoc also?
I'll go to that. Yes, next. Next step. F5. You go to the next one. See, now you find the individual differences. X1 difference X2, X2 difference X3, X3 difference X1. I am getting 3 mean values. Yes or no?
Yes.
Okay. Now, instead of that is big. Remember the formula which we are using is sigma d equal to standard error deviation. Sigma d equal to
Sigma d square.
sigma m1 square plus sigma m2 square. Is it not? Remember? Only we did. Okay. So sigma m1 is sigma 1 by root of n1. So the whole square. Sigma m2 is sigma 2 by root of n2. The whole square. So for every combination you have to do this. 3 sigma D's you have to find. Because we have got 3 combinations, no? X1 bar, difference X2 bar. For this sigma D. Similarly, X1 bar, difference X3 bar. Another sigma D. And X3 bar, difference X2 bar. Another sigma D. Is it not? Instead of that, you can combine and compute one sigma D. Pooled sigma standard deviation. Sigma error of standard deviation. How to get it? Square root of the variance. Not variation, variance. It is variance. It is corrected. It is spelling mistake. Variance of the within group. The error component is there, no? In the table previous, sir? Previous. This one. Variance. Square root of it will give the combined standard deviation, sigma D. Yes, go to the next one. Understood? Square root of the within will give you the combined variance. So 4.03. So now standard deviation is, you remember? 1 by n1, 1 by n2, we are putting it here, no? I am including it here, 1 by n1 plus 1 by n2, square root of it. So this is 1 by, what is n1? The first 7. Second is also 7. So I am getting it as, so standard deviation is sigma dw into square root of n1 plus 1 by n1. So this we found to be 4.07 into square root of this is totally we are getting 2.158. I am only combining, instead of doing separately, I am coming to arrive at one value, I am going to compare with that. Okay, so after finding out this, what is the formula for T? Mean difference by sigma D. This is the sigma D I am getting. Okay, so table value of TF is, for TF 18 is P is 2.10. So the T need, when this value is 2.10 only, more than 2.10 only, I will accept. I will reject, sorry, I will reject. Okay. So I put in 2.10 here, 2.10 equal to, T, see, T equal to, mean difference into sigma D, is it not? Sorry, mean difference by sigma D. So T into sigma D equal to mean difference. Is it not? Yes or no? We had mean difference. We found mean difference earlier, sir. So now you want the T value to be 2.10 from the table. Into sigma D value to be 2.158. Okay? This should be greater than the mean difference to reject. Is it not? If you want to reject null hypothesis, this value should be greater than the mean difference, individual mean difference. So you are multiplying, here I am getting the value 4.532. If the individual combinations are greater than 5.32, those groups are only differing. Got the point? Is it confusing? Tell me the real truth. It's confusing. See, when if you want to do 3Ds, you have to go to this everywhere. Instead of doing separately standard error of deviation, you are going to have a combined standard error of deviation. Okay, you are leveraging, having a combined standard deviation. How to find the combined standard deviation? Taking the square root of variance of the within group. Variance of within group is MSS. You found it there. Error component. I am taking the square root of this, I am getting it this as 4.3037. That multiplied by square root of 1 plus 1 by n2 will give you the total sigma ED, SED. I am getting SED. Instead of doing every time there, the denominator, see, for the first group like this. For the second group, this will become sigma 2, this is n2, okay. This will become sigma 3, this one. For the third group, this will become sigma 1 squared by n1, the whole square plus sigma 3 squared by n3, the whole square. Is it not? For the third group. Instead of doing all the three, I am putting and getting it as 1, 1. Combined. one standard of the deviation. After this, okay. This is the T formula. M1 difference M2 by sigma D is the T formula. I am getting the T value from the standard table. The standard table says 2.10 for the degrees of freedom. I have to multiply these two because I want this mean difference. This to be significant, multiply these two, sigma into sigma T into sigma D. T value is 2.10. Sigma D we got it here. Multiply, you will get one mean difference. Already you have got mean difference. What is this problem? Here mean difference are there. So this value should be those things which are greater than here about this value will be significant. Among the three combinations, which is greater? I am getting, if the value has to be significant, the groups has to be varying, those values should be greater than this value. This is a standard value now I am getting.
But if two groups are less than that value.
So these groups are not differing. Okay. Only this combination is differing. Understood? Got it? If the mean difference has to be significant, it should be greater than this value. This is not greater, this is not greater, only this is greater. So group 1 and the students taught by traditional method and multimedia are only differing.
Remaining two methods are same.
Project method is
There
same.
is no significant difference.
Do you get the point?
Yes.
I am given. Comparing the mean difference, this we conclude only one mean difference, x1 difference, that is what x1, x2 is significant. We conclude that multimedia method is significantly superior. How did you say multimedia is significantly superior?
Because of the calculated value is high than table value.
Because of this. Among these two, they are differing. Which is the best method?
Multimedia.
Why?
Why?
Because
the calculated values are
given value, but
see, this we have come to the conclusion this is higher value.
Yes.
Now there are only two groups are differing. Traditional and multimedia. Among the two groups, which method is the best? Why? By looking at the mean. Look at the mean. Now look at the mean.
Yes,
That is more. So multimedia method is the best method.
Even though we are concluding the significant level, we are comparing the two calculated F value and T F value.
Yeah.
Calculated F value and calculated T value.
The differences.
With the help of these two, we are whether it is significant or not significant,
That's
we
it.
finalize.
That's it. This is what is known as post-op.
8.57 traditional car, 15.43.
So these two methods, there is no significant difference almost.
Traditional method, project method is same.
Same.
And then similarly, project method and multimedia method also same.
We cannot say same, but there is different, but there is no
Not
significant
significantly
difference.
different. That's what.
Yeah.
Always statistics is differing only. Right? Minimum difference is there, but not very noticeable.
There is no significant difference.
Not very noticeable difference. Definitely difference will be there. Any human being will have some difference. Okay. So this is what you are doing now.
Yeah.
Understood? Yes, ma'am. If the ANOVA is not significant, we will not go to this part at all. We will stop there. Go to the previous slide. Go to the previous slide. See, if this is smaller, you will say not significant, you will stop here. You will conclude all the three methods are similar.
But here is a significant level is 3.55. The
Here
calculated
is
value is 5.
more.
Yes.
Suppose,
There is a significant difference is there.
but where is the difference? Next step, post on.
Yes. If
So-
there is no significant difference,
We'll
there is
stop
no
here.
need to go for
Go to that at all.
forecast.
Suppose this value is
If
2.58.
it is less than this 3.5, there is no need to go for
Suppose
error.
it's 2.5. It is less than
3.5.
3.55. So no difference. You stop there. The three methods are similar. They are not differing.
If there is a difference, which method is
Method
effective, which
better.
method is not effective?
Therefore, we are going for post.
Yeah.
Clear?
Clear.
This is about ANOVA.
What about students?
They are very tired.
No, they are getting knowledge.
Okay?
Right.
Now, next slide. Next slide. This is very confusing. Let us skip this.
Between the groups.
Okay. Next one. Suppose nowadays, this I give an example. Nowadays, when they are using SPSS, we write like this. We don't give within, between and all.
Oh.
This is how we write. This is the nicest way of writing. So we will say the first group. This is one of a PhD candidates table. Actually, I will put this. I copied it. Government school, spiritual intelligence, emotional intelligence, educational aspirations. Main SC, there are three kinds of schools. Government school, government aid and self-finance. So main SC getting. I am getting F ratio to be this. This F ratio is significant. P value is this. P. So it is significant. Which all groups differing? I went to this is SPSS output. From that we are inferring. From the SPSS output, I got group 3 and 2 already differing. 3 commands.
In this regard, I would like to ask one question, madam. If you give directly, the SPSS gives this type of result.
This SPSS will not give you this type of result. I pulled out from the table.
Okay.
Okay, it will give elongated difference. It will give. I will pull out. This is what we are presenting nowadays.
Okay, like this, if it gives the SPSS package, there is no need to go for testing of the normality.
SPSS already first step is their test. Before doing ANOVA, so their first test. The statistician will test for normality. Then only he will apply ANOVA. This is like.
Why? Because nowadays they are not going for testing of the NPC. Directly on the basis of the results, they are writing the report.
No, they have first test. But they will not show it in the thesis. Without testing normality, they will not put this. Starting first, the first step is they have to test it now. Okay? So this is why now we have nowadays we are presenting a meta. Yes, next. I have given the explanation for that. Okay, so this is what I have given. F ratio calculation in this management schools, not by level, not by we go for even higher. SPSS will give all that. Not by level. So I am going for DMR postdoc. Duncan multiple range test. Duncan multiple range is DMRT.
It is applicable to the F test only.
Yeah, this postdoc. No, wait, postdoc. Yes, postdoc. There are a number of ways of doing postdoc. Different studies is given different method. Duncan, Sheffy, Tucky, so many methods are there. Then we DMRT. We do that. Okay. Yes, next one. This is what you are doing. This is what you are presenting.
Yeah.
I am given that for that example also.
Yeah, this is the old style.
Old style. The latest style what I have given. Okay?
Okay, between the group, total sum of squares, degrees of freedom,
Mean squares,
squares.
F ratio not significant. No, it's not because the T value, the table value is small, so it's not significant.
F ratio not significant. Level of significance they have not mentioned, ma'am. In the previously they are using the single star or double star. Or
That is what you can put.
this is a 0.05 level, na?
This is 0.05 level.
How can we understand that? There is no symbol at all. Level of significance.
Not significant, no need to give the not
No need to give any significance.
level. No need to give the level.
If it is not mentioned any, it's automatically understood 0.05 level.
Yes. Okay, because higher is not okay. No, I am going for lower. Even lower is not okay. So I am keeping back. Okay. Yes. Next one. Next slide.
Aggregation.
I have given an explanation for that. Yes. Go to the next one.
Okay.
No, aggregate.
Next. And this I told you.
Yes.
Yes.
Please show me that. Just previous text.
Previous.
Yeah, P value.
Ah.
Here you can see.
001, 006. SPSS will tell you these values. Anyway, this is 006, no? Less than 001 only. 011. Is it not? 006. Even more precise. Very precise. Is it
So,
not?
ma'am, according to that the values, there is a significant difference. Why? Because the F ratio is
5.172.
high compared to the table value. Na?
This is not 10, this is P value.
P value.
Level of significance.
Yes, level of significance.
At this level of significance, this is 2. This is significant.
Yes.
So after postdoc, I am getting only 2 combinations significant. 1 and 2, 3 and 2. This with this. Whereas 1 and 3 is not significant. This is not significant. Okay? Only 2 combinations are significant. Yes, next slide. I am giving the explanation for that. Yes, this is over. That's all now. Okay? The 2 way, as I told you earlier, is very basic. 2 teachers, 3 groups.
The I was asking it out.
This is only 1 by n hours.
Only 1 hour, so much.
Oh, n hour is more than n hours.
Even more steps.
2 n hours. Okay.
A questionnaire is given. You told that students will copy the answers. And a few days before, when the other sir was explaining, the central tendency error will be there. So, the middle part, if you mostly easily how can identify which answers are correct, which are don't have error. Central tendency error, if you remove the extreme part of the first answer, that agreeable, or the final answer, the extreme last, these both can be correct. Because of the central tendency error, the middle part may be error. Is it correct? Is it related to this?
That is related to tool administration and taking the data. Okay. So when you have this central tendency error, this will be reflected outliers. Outliers I told you, no? Remember I told you about outliers.
Yes.
Okay, the extremities. So that will be removed. Those tools you can just set apart.
Here also you are removing the human errors now.
After taking these two ends and even within that end,
Which is significant.
even those ends will have certain errors, human errors. Okay, that errors are scientifically removed through this error variance. Okay, even with a good person will give good values when discussed with his friend. Even the bad person will give bad value discussed with his
Yeah,
friend.
there are many dimensions.
So those things can also be removed using the error variance. Okay?
Thank you.
Anything else?
What's your problem?
And as you told, there are two ends are there. For the two ends, t-test is enough.
Two groups.
Two groups. Two extreme groups are there. The t-test is enough. In a 5-point scale, again I am coming to the central thing.
5-point scale, don't bother about the scale. Take the total score. Suppose you are giving a personality test. What is the total score for the individual? That is only taken part in this.
Yes.
Not the individual statement scores we are not taking. Maybe you are giving an attitude scale. Attitude towards research. 20 statements are there. 5-point scale. Maximum score is 100. Okay, one boy is getting 62, another boy is getting 74. I am only getting 62 and 75. I am putting them for the t-test.
Yes.
I am not bothered about whether they are given 5, 1, 5, 1, 5, 1. No. Do you get the point? Okay. So, only the total score you are taking into consideration for the t-test. Not the individual statement scores. Okay? What Sarah told you, know, if you are going to put middle, neutral thing, you will remove that fellow.
Yes.
Yes, exactly.
That is due to central tendency.
Undecided, doubtedly. The short
Because
point
he is
says
not
that.
given two opinion. 100 truths you are given that two. 20 fellows who has put neutral. Or to some extent agree, to some extent agree everywhere.
Third point.
Some neutral, to some extent disagree. So these are the second point, third point, fourth point. You remove the fellow. Don't simplify research. You throw away his questionnaires. Remaining you take. That's what standards.
Yes, exactly. Third point says always doubtful, undecided.
These fellows are sitting on the wall. The cat on the wall. This fellow will fall this way, that way. So you cannot rely on this statement at all. Because he is not confident. How can you say neutral? Do you like research class?
Yes.
Neutral. Do you like statistics class? Neutral. What is this fellow?
Yes, exactly.
How can I take it from the research? No. He is not giving any true opinion. He must say, I very much agree, and I very much disagree, or very good, or not very good. Is it not? Neither agree, nor disagree. What is this fellow? So remove it. Don't interview for the research. That's what Sarah.
Yes, exactly.
Then why that point is given in the scale?
5 points. Hello.
There are situations, some situations where you go for neutral.
Sometimes you can use it.
Sometimes.
Yes.
Not always.
Yes.
Okay. Yes.
Very nice. But tomorrow or itself right now or tomorrow, one most important topic is it's possible. In Excel sheet or SPSS sheet, how to enter the data, for example, attitude scale, how to enter the data in Excel sheet.
श्री गुरुभ्यो नमः। सप्ताहात्मक कार्यशालायाः इदं दिनम् अन्तिमं दिनं, तत्र तृतीयसत्रं पुनः चतुर्थसत्रे अस्माकं कृते पैरामेट्रिक टेस्ट एवं नॉन पैरामेट्रिक टेस्ट विषये अस्माकं कृते सुचारुरूपेण पाठितवद्भ्यः आचार्य एन् कलै अरसिमावागेभ्यः अस्माकं कार्यशालापक्षतः एवं विश्वविद्यालयपक्षतः तथैव विभागपक्षतः धन्यवादान् वितनोमि। एवं आगतेभ्यः सर्वेभ्यः अध्यापकेभ्यः पुनः धन्यवादः इति मत्कर्मणात् विरमामि। धन्यवादः।